All right, gonna get started here a minute late, but not too bad. All right, so I guess first thing, I have a new microphone, so any new piece of equipment introduces a little bit of uncertainty. So if I'm making mistakes, I blame it on that. There's your disclaimer. But hopefully it sounds better. Um, I started out these sort of as a substitute, or I don't know, not necessarily a substitute, but for myself to some degree to simulate pair programming, because it's just me working on this stuff right now. Um, and so I didn't want to do a lot of investment in equipment to start. I think that can be sometimes you can buy stuff instead of doing things. So I've done this for a while now. I plan to keep doing it. So I invested in a microphone. I got myself a blue. I guess it's not actually the Yeti. I think Blue is the brand, but anyway, it's the Nano. It's like the Blue Yeti, but it's a little smaller and fits on my desk better. It's a little cheaper. So I did a little testing. Sounds good so far. If you have any problems you observe as a listener to this, let me know and I'll make adjustments. But no one's complained about my old janky Jabra speakerphone so far. So hopefully this will be an improvement. And, all right, so let's get started here. Oh, I will say one thing that is slightly more awkward about this is, like sometimes I'll mute to clear my throat or something like that, and the mute on this is a little harder to trigger. So if there's slightly longer pauses, that's why. Okay, let's get started here. So let's see, let me get this out of the way. Actually, let me just put that in a different window here. So as I tweeted out here, we're going to look at a few different things, kind of to boot my brain back into this space since I skipped a week for being sick. But we're going to look at functions and queries. This is all within the context of experimenting with XTDB, formerly Crux, and Arweave. We're going to look at functions in queries, XTDB queries, look at the XTDB SQL interface, connecting that to Metabase, and then calculating block transaction rewards for Arweave transactions. All right, so diving into this, I was debating a little bit about how I would show the Metabase stuff, because there's a bunch of sort of nitty-gritty opsy things there that I don't really want to get into in the stream too much, but I do want to show what you can do, just to kind of show where I'm going and some of the things you can do connecting XTDB to other systems. Okay, so what I have here, this is Metabase, which, I should explain what Metabase is really quickly. So Metabase, let's go to their site where they say it is. Make the easy open source way for everyone in your company to ask questions and learn from data. So obviously they're trying to target businesses here. I think it has a lot of value in that space. But you can think of this as like a business analytics platform that you can connect to. Maybe platform's the wrong word. It's a tool. It's a tool for visualizing data and working with data that you can connect to lots of different databases. I use it to connect to Athena, which is basically Presto on AWS as well. You can connect it to any sort of JDBC-based relational database. And then ask questions about your data. It also happens to be written in Clojure. That's how I became familiar with it. It's not why I use it. I actually just think it's a really good tool compared to other tools in the same class of tools. And so it's effective. I used it in my previous job. I'm using it for internal stuff for what I'm working on now. And I want to use it to visualize Arweave data too. And other things that are in this space would be like, I guess, I've never used it myself, so I hesitate a little bit to say this, but like Tableau, Power BI, are some of the older, bigger players. Superset is sort of a newer open source thing. Also, it's in the same space. There's a lot of things like this, but Metabase is pretty quick, easy to set up. It's nice. It's written in Clojure, which I do like because I can then go, and it's open source, and so I can go poke around in the code if I need to figure things out. So yeah, it's a good tool. I recommend it. So what does this look like? I'll just start at the front page. By the way, well, I don't know. Probably no Metabase people will ever listen to this, but I find the landing page of Metabase confusing. It's just like it's too open. Like I never quite. Maybe I'll get used to it in time, but it's always confused me. Like, why does this page look like this? But anyway, so you have some dashboards here. Like there's a sample data set. These are the data sets down here. There's strong pool, which is the sort of internal data I have for the mining pool. And then there's Arweave data, which I've just started to work on. And by just started, I mean a couple weeks ago, but I haven't, I work in this part of the system in spurts. So, okay, so what do we have in here? We have one data set. It's block attributes. Let's look at that. So we can, just shows it in tabular form. I'm not going to do a lot with it this time in Metabase. Maybe in a future stream, I'll get into visualizing it. But anyway, the point is, this is being exposed via the SQL interface on XTDB, which I'll show more about that in a little bit, and then connected using a kind of a hacked together driver for Metabase, but it works. I mean, so don't let the hacked togetherness of it stop you. Let's see, crux should have it here. Yeah, so I made a fork of it because there's one little change I had to make to get it to work with the latest. I think this function here is sort of an internal interface in Metabase, and I had to add the exclamation mark. I didn't dig into it too deeply because this is all I had to do. Once I did this, it worked. So if you're trying to get started from scratch with this, following my footsteps for some strange reason, I'll just throw that in the chat. You can use my fork of it, and I don't know. I'll make myself a note to do a PR for that at some point. I haven't done it yet just because I didn't look into it too much, and I didn't want to submit a PR when I didn't really know if that fully know if that is the right change to make. Another thing I ran into too, just to sort of FYI in case anyone's following along. Metabase recently changed their build system. They moved from lining into tool steps, and that kind of messed up the build process in here. So what I did is I just compiled this thing with the version of Metabase from right before they made that change, and that worked just fine. So again, it's kind of like a little hackish to get this going, and I can link to that too. That's a public repo. I have a Metabase Docker container, and I'm actually building this in the Docker file as part of a multi-stage build. So I'll just throw that in the chat as well, in case anyone wants to look at that. Okay, so yeah, I think this is, I mean, you got to know Docker, right, and Shell, but this is fairly self-explanatory what's going on here. So if you wanted to build it by hand, you could just do the same steps I'm doing here by hand, and then piece that together along with stuff from the README, which I guess I closed that. I should not have done that. Should open a new tab. The README tells you stuff about building it, so. Okay, so yeah, hopefully that's enough for anyone who's following along and might also want to do this, to piece together how to do this yourself. I would love to fix some of these things, but my time is limited in terms of where I can put my focus right now. The behind the scenes here is working on product, have sort of a fixed runway, and time I spend making PRs and doing things like that is not time I'm making progress on other things. So gotta be careful with my time. Okay, so that's sort of how you connect Metabase to Crux. I guess I'll show one other thing here, which is databases. Yeah, there's still some Crux stuff in here. I think I just said Crux too. How you connect Metabase to XT. The driver still refers to it as Crux. Kind of a long tail on getting all the Crux things out of the internet. So yeah, I guess some gotchas I ran into, which you will probably run into. I don't think this username and password matters that much. I just pulled the defaults out of the driver, put them in here, which is DB user, DB password. I'm just relying on AWS network security to secure the database. Again, it's called Crux here. I just went with the default. I don't know for sure if this matters. It certainly didn't break with the XT name change, and I don't know if changing it to XT right now would break anything. Anyway, this is how I set it up. This is the default port too. One thing here, this says host. If you put in just the host name, you'll get confusing errors. So you have to include the HTTP in there. And then I think everything else is pretty default here. That's interesting that this is checked. I don't think it's actually going or using SSL. But anyway, I didn't change any of the other defaults. So yeah, the gotchas here, you'll have to fill in something here, just DB user, DB password, or DB pass, something like that. Worked fine. I actually think you might be able to put any value in there. Not sure, but these were the defaults there in the driver code for Metabase. And then make sure you have the HTTP there. Okay, yeah, so that's really the nuts and bolts of getting Metabase connected to XT. Exit admin, go back here. Again, I think I'll save visualizing or playing with this much to a future stream, but just to show you, like, oh, we can, you can do stuff you'd expect to do, right? Like sorting works. You'll see the timestamp here is stuck from a few days ago. This is because I have a process running that should be ingesting all the time, but it gets hung sometimes. I'm not sure why. I'm trying to run all this stuff really on the cheap, so it's like in a not huge Fargate container, and it could be running into issues with that. But I guess it's at least encouraging that you can run this stuff on fairly stripped down containers, etc. Okay, so I think that's probably as far as I want to go with the Metabase exploration, and then I'll kind of work back from here and go into what this looks like in the code. Like, so far we've been running data log queries. How do we get the SQL interface? And yeah, how do you hook it all together on the other side? So I think I'll start there and then work back to some of the other topics. Okay. Yeah, I was just pausing for a second because it's like, what all did I change? I should keep running notes on this so that I can quickly go over what is changed. I mean, I have my Git logs, but that's not the most convenient format. So one thing I did change, and I think I'll mention this and come back to it, is I had these side effecty things, which are still in here, that were doing a bunch of transactions into XT to load the data. And I've switched it around so that I fetch a block at a time and get all the transactions for the block. And then from that, I just have a function that takes a map that has block and transactions. And actually, yeah, I don't know. I was thinking, it's like, would it be cleaner if I destructured this here? Whatever. It takes a map that has a block and a vector of transactions in the map, and then it turns that into a data structure that represents the XT transactions all in one go. So that means I can save that data and then transform it to test and play with, and that's nice. Or arguably, maybe I should have done that to start with. I don't know. I tend to write very, very messy code initially and just slowly clean it up over time, which works great when I'm working on my own. I have found more difficulties with that approach when you're working in organizations, because often they don't let you really go back and do the cleanup. But when I'm left to my own devices, I like that, because I don't know. It's sort of like if you're writing, just getting a bunch of thoughts out and then revising, I find pretty effective. That's how I tend to code too. Okay, so I made that change. I'll probably go back and show more about that later. I also rearranged the namespaces a bunch. I don't think that's super important to go into details about on the stream, because I'm just going to jump around files and you'll just see the files anyway. The thing I want to start with here in the code is looking at this definition of a SQL table. So the sort of native language of XT is data log with some embellishments like the pull queries. If you want to hook that up to SQL, there's a little bit of I don't know, I wouldn't go so far as to call it an impedance mismatch. I think that's kind of the wrong way of saying it, but the shape of the data is different. So data log is dealing with these entity attribute value triples, and SQL is relational. It's dealing with relations. Although, you know, you can actually think of the attributes as relations too. But anyway, they're sort of a fixed set of sort of a narrow set of relations, all triples. But yeah, anyway, so there's you want to map this sort of triple based model to a relational model, which is wide. And so this is what that looks like. I'll just pull this out here. So what you do is you put a document into XT. I'll just separate this. So this is just my data structure with keys for the documents I'm putting in. This is just sort of a convenient way so I can load it elsewhere. But right here, this is the XT document that gets loaded into the database. And so you have an ID here, which is the ID for the SQL mapping you're defining. Then the table name, that's the SQL table name, and the table query, and then the table columns and the type mappings for the columns. So the query is just a data log query that, you know, has our conditions here. It's joining a bunch of things. This is the block attributes one, so it's just joining a bunch of things on block attributes. And then it's spinning out a bunch of fields from block attributes. And then down here, you know, because XT is sort of, it's schemaless, so any kind of thing could come out of here, right? Like height could be a combination of numbers and strings and whatever, but we happen to know that height is always a big int, or actually it's I forget what all the types you get, but anyway, in terms of what SQL cares about, we're calling it a big int. And really all of these things are like this. They're all homogeneous. There's no you know, there's no variety in terms of the types that come out of the block size, so that makes it quite easy to map to SQL here. So we define for each of these things that we're pulling out in the find, we define the type, and then these names get turned into the column names in the SQL query. So we go back to Metabase. You can see Metabase is doing a little more munging to like make these things polite looking. Wonder if I could, let me ask a question. So I'll do a native query here. Select star from crux. I think it will be okay if, yeah, there we go. It'll be okay if I do that. Probably don't need a semicolon. So I just want to show you the raw data as it comes out. Oh, that's interesting. That is really interesting. I thought that it underscored those, but maybe not. Huh. Well, I was thinking it actually did a little munging of the dashes to underscores. But anyway, so here you see the raw table columns coming out of here. Yeah, so this is a really, really simple example. I'm restricted, by the way, just to explain what's, you know, I've iterated on this. I haven't reset the data, so there's sort of a mismatch of of data depending on what time in the database you look at. So this is restricting it to data where the schema is actually what I mean. If I think if I remove this, some of the types break, but that's not because of, that's just because of me iterating on it and not, you know, cleaning things up. At some point I'm just going to reset this whole thing, start from scratch and pull the data in, but it's not, things aren't solid enough for me to want to do that yet. Yeah, so that's really all there is to it. There's not a ton to this. One interesting thing that I came across when working with this, which is, I mean, it totally makes sense, but when you're using XT, you know, the way it's working inside is it's reading from a transaction log, applying the changes to the local indexes, and then updating its local state. So you have this notional state of the database that's a combination of, you know, it's like the applied transaction log. But if you start up a database, like if I restart my container, it'll pull a snapshot, start from a certain point, and then keep going from there, but it might be behind. So if I change this schema, the change itself is somewhere in that transaction log, and if you have a reader of the transaction log that's behind, it won't see the schema change. So that's just a little gotcha, that if you apply a schema change, you have something that's behind. You just have to remember, oh yeah, the schema is actually part of the database, so it doesn't get applied till the database is caught up with wherever the transaction log is, which is, you know, it's not surprising if you're thinking about how everything works. It can be surprising if you aren't thinking about that. You apply it, and it's like, where did my change go? It's not there. Well, okay, your database has to catch up. Okay, so I think what I want to do from here, I've sort of laid the groundwork, and I want to work on defining more of these schemas and also looking a little bit more at how to do more sophisticated things in the Crux queries. So, let's see. I said Crux again. Dang it. It takes a while for my brain to fully update too. The XT queries. Yeah, so in particular, if you remember, you know what, I should have pulled up, I'm sorry, let me just do this real quick. I should have pulled up, Jeremy Taylor tweeted a bunch of stuff at me from, what's the easiest way to find that? Maybe look at his. Yeah, let me expand this. Sorry, I meant to get this up beforehand, but it slipped my mind. Yeah, okay, so that's the byte array stuff. Talking a little bit, I mentioned some stuff just about how distinct works. Yeah. Okay, so I think probably, I think this is the thing I want to focus on. Calling a function on result sets, so you can subquery extra clauses. Yeah, so I want to show this. So if you remember, which you may or may not, we're saving the tags like so into the database, and this is just, we're not doing any transformation of this value coming from Arweave, so we're just taking the name out of the tag we get from Arweave and the value. And if you go look at view block, let's see if we get, No. I'm just trying to find, yeah, here we go. So let's go look at this. So Arweave, TX, this. Oh, I should do this in the shell. Hang on. Oops. So I want. Yeah, so this is what I wanted to show. You know, all the binary data that's in these is base64 URL encoded. So this is the actual stuff we're storing in a database. And I want to keep it this way because, you know, there's nothing about Arweave that says that these are UTF-8 strings. People usually treat them as UTF-8 strings, but I don't want to bake that into how I'm storing it. So that leaves you with a problem when you're ready to query because, you know, in particular, so if you're trying to say, get me all the values for a tag with this name and value, that's fine. You can URL encode it on the way in, like UTF-8 decode, URL, base64 URL encode it, and match that against the values that are in here. If, on the other hand, what you want to do is pull out the name and value, well, now you have to do some transformation. And you could pull those out and do things with them outside of the query. But what if you want to, say, do an order by in the query? So now you need to do the transformation somehow in your query. And you can do that in Crux. I'm sorry. I'm so bad at that. You can do that in XT. I would feel like I did way better on this a week ago. Maybe I don't know, maybe being away from this a little bit has sort of reset my brain there. So yeah, you can do that in XT, and that's what we're going to do. So sorry, just trying to think the best way to work on this. Oh, yeah. So one other thing I wanted to show here. Right. So I just wanted to point out in the XT docs, you know, they have a pretty good, you know, I would say reasonably good documentation of how the queries work. But there's a lot of stuff, a lot of details, I would say, that you could maybe figure out from this, but if you really, really want to get the nitty gritty and see a lot of examples, I highly recommend, I tweeted about this too, but I highly recommend just looking at these examples in the tests, because they cover, you know, a lot of what, maybe all, I don't know, you know, there's certainly, you're writing tests, you're trying to cover a lot of the surface area. So you can find a lot of stuff in here about how queries work. Yeah, so let's dig in and try to do some of these queries where we're transforming using a function in the query itself. And I haven't done this yet, so you'll see me learn as we go here. So let's do some simple experiments. So I think I'm just going to look for identity. What I want to do is actually sort of just generate some data to use in the query. So instead of querying stuff that's in the database, just have some synthetic data that's right there. And I'm pretty sure there's examples of that. Just looking for them. Let's see, test circular dependencies. Oh, I see, that's fun. So testing things referring to themselves in the queries. I think there was also one of these tweets here. May have had an example of this too. Oh, that's like some example. That's some inline code. Yeah, interesting. See if I can find it here. Here we go. Test tuple returns. So let's see. How is this working? So we're doing a find. We got xy. We're calling a function in here, and it's returning values like so. Okay. Yeah. So let's take this. Not sure if this is the optimal way to generate some data, but you know, it's a way to generate data, so we'll go with it. So yeah, definitely do not take this as, you know, I'm just working off the examples here, finding something that does what I want, copying it. So don't at all take this as like, oh, this is the way I should. This is a way you can put data into a query. Not necessarily the best way, it's just a way. Do we want to leave this? Sure, we'll leave it threaded for now. That might be useful. We're already connected. I think I need to load this. And probably a bit behind the transaction log here, so who knows how long it will take to catch up, but that's fine. The state of the data is fine as is. Okay, so let's run. I'll leave that dangling there so that I can easily put stuff in. Okay, let's run that. Yeah, okay, so that's good. We're treating each one of those. I think I'll just format it like that for my sake. So, okay, so we're getting the, what am I trying to say? Each one of these individual things in this set is being treated as, don't know what the best terminology is in XT. It would be, say, a record. I don't know. They're being treated individually, and we're returning them each individually. So yeah, I'm struggling with my terminology a little bit. That's opposed to, you know, if we had multiple, you could imagine this returning these all at once. And so if I put another, yeah, I really gotta get my words straight on this before I talk about this more next time. But actually, let me take one of test relation. Okay, yeah, they're calling them relations. So yeah, each one of these is being returned as a separate relation, as opposed to the tuple. Yeah, I guess I should look at the test here. The tests have the terminology they're using, which is good enough. So in this case, if we return the vector and destructure it, I'm not sure what the right terminology is for what you're doing on this side. I'll say destructure. So I think, let's see, let's just do an experiment. So if I do x, y, z, will this end up, I think this might break. Let's see what happens. Yeah, it doesn't like that. Let's try. So if I were to do that, what I would expect is that each one of these ends up being that. So one relation. Yeah. Yeah. So we get one relation out versus if we put it in a set. Okay, get one relation out versus putting it in a set. What did I do? Oh yeah, I think I gotta put this in vector again. No, what did I do there? That. Oh, I still have the z. That's probably what it's complaining about. Yeah, versus if we put them in a set, then do the sort of nested destructure on this side, each one comes out as a separate relation. So hopefully that made sense. Basically, I could return either tuples or relations from this destructuring thing here. Okay, so this was all just setting us up so that we could apply some functions to this data. And that's actually what we're doing already. So the identity is a function. But we can apply other functions. So let's do something simple. So let's put z back in there. And I believe the syntax here is vector function in the first position, and then binding form, maybe is what that should be called. Yeah, do not. I almost hate saying some of this stuff because my experience is as soon as people hear something or see an example, they tend to just copy that. And I don't know if all the terms I'm using are the best terms. So, I think that the tuple and relations reasonably safe because they're in the test here, but like binding form, that's just something I pulled out of my pulled out of my brain on the fly, and that may not be the best term for this side. So anyway, what this is going to do, hopefully, well, let's run it first and I'll say, yeah. So what it's doing is it's going to take this function, we're going to apply this function to each record relation, each relation, and then produce a new value in that same relation that is the result of applying this function to these things pulled out of the relation. Okay, so with this, let's go ahead and take let's keep moving this to get closer to the actual thing that we want to test. So I'll just take some of these. What is this? What is this transaction? Okay, cool. So I just wanted to make sure it wasn't anything like crazy in the transaction before I like use it as an example over and over again. Okay, so let's take doesn't really matter what. We'll just take the names just so we have some nice data here. Take the name. Bloop. Take this name. And take this name. Yeah, so we have some nice base64 URL encoded data. Change this back to just X, and we'll just comment this part out for the moment. Just check, make sure we're doing okay before we do anything with it. Okay. So this would be similar to, we're running a query over tags. We're pulling out some tags, some tag names that have these base64 URL encoded values. And then we want to do something with them. So let's see. Where are my utility functions? Yeah, so they're in util. Oh, I'm going to bytes. Do I have to write? Oh no, I do have some. Okay, cool. Okay, so let's put schema over here on the, util over here on the right. Go back to our indexer namespace. Okay, cool. I do have util. So quickly here, util b64 utf8. So that should take, if I remember how these work correctly, should take this. Okay, and we get the, okay, so now what I'm not sure about, and we'll find out here, is I do not know if I can do, so we'll call this Y. I don't know that the aliasing will work. I think not, but let's try it and find out. Oh, right, because I'm just printing X. Interesting. I wonder if it, well, we'll find out. Oh, that did work. Interesting. I was expecting to have to fully qualify that. How did that work? What do we get if I evaluate this? So I'll tell you what I was expecting. I was expecting this to blow up and have to do something like net, strong pool, indexer, you know, like that, fully qualify the name. Does it say that we have to? Functions. Custom functions and advanced examples. Custom predicate function. You can, the fully qualified name in the data log, these custom functions can be passed into DB. Interesting. So here, I don't know if there's some subtlety or something that's changed. This is where I got that idea from, I think. The fully qualified name. These custom functions can be passed the DB query context using the dollar argument convention. Interesting. I guess that means that we could pass, I think that means, well, you know what, let's go look at the tests, right? So let's see, do we have dollar in here doing anything interesting? Get some. Yeah, so here we have an example of a function that's taking the database query context. Are those all commented? I wonder if they are. Yeah, I'm just noticing those tests are commented out. I don't know if that means that doesn't work or what. Well, here's one where it's, so clearly, let's see, is this commented? No. Okay, so this, yeah, passing the dollar in must work. I'm not sure why those are commented. I don't know the context of what's going, oh, interesting. I'm getting distracted here. Yeah, so I see a lot of examples in here where they're not using the fully qualified namespace on the function. So I don't know if that's dated or this is something where that's kind of a gotcha I'll run into later, why that's not, you know, why I should do that. I guess I'll just say that's what the docs say. I think the docs say, I think that you should be using fully qualified here. It works without it. I'm gonna keep using it without it for now, but you know, I guess you've been warned. I'm not fully sure if you should or should not. Also, I believe, well, this is muddying the waters a little bit. When you define an aggregate, let's see, yeah, this is just a different thing. If you define an aggregate, I think you do it as a multi-method. It's a different thing though. So I don't think that has any bearing on the functions. Yeah, interesting. So it looks like this will work. So what I'd like to do now is just define a tags table. Let's do that. Okay, so get the indexer, get our tag schema. Okay, so what do we have here? Let's do ID. Let me just clear this out so it's not too confusing. Just thinking from the top here, like what are the attributes we want to define in our tags table, or the columns, I should say, we want to define in our tags table. One thing that is driving me a little crazy with this new microphone is it has you can plug in headphones, you know, so that you get the nice feedback of your own voice with zero latency, just the way the mic is hearing it, which is great. But now I have this cord in front of me that's kind of messing with me. Just getting a little distracted with that. Figure that out for next time. Yeah, so TX. What should we call this? I actually haven't defined one like this yet, so I think I would call this TX. Oh, I don't even care about linking. I just want, okay, let's do TX attributes ID. So that's going to be this. This is so we can do joins. By the way, I haven't looked into this yet, but I assume that when you do joins on the SQL, what it actually does inside is it just makes a big data log query and then lets the data log query optimizer optimize all the joins. Because like, why would you also write a SQL optimizer? I call this the index and then the name. Yeah, so let's do name, value, and then UTF-8 name and UTF-8 value. I wonder, I might need to make this a little more sophisticated and somehow check that those, can UTF-8 encoding completely blow up? I'm not sure on that. Like, will it decode, but just decode nonsense sometimes? I have to check. What I'm wondering is if I ever get into a situation where like UTF-8 encoding would, you know, throw an exception, and I actually have to check prior to decoding whether it's. I guess I could do that in my decoding function though, so that would be fine. Yeah, I think this should work fine. Yeah, so I want to preserve both so that when I do queries, you know, if I wanted to query with the base64 URL encoded value, I could do that, or I could query with the UTF-8 values. Just preserve both of those. Okay, so what does this look like? So we have the ID. We have, let me just copy this. Loop. TX attributes ID. This will be index. I don't know that I really gained anything from copying those, but that's fine. Name, value. Okay, now we do our little function magic here. So we do like this. Is that right? Let me, I should have kept my old query up. We want to do this. So this would be UTF-8, or sorry, util UTF-8, no, base64. There we go, that one. So we want to take the name, and then we'll output the UTF-8 name. And same thing with value, UTF-8 value. Okay. Yeah, let's run this. Limit 10. Sure. Not totally sure if I can. Yeah, okay, it worked fine. I'm a little bit wary of just running stuff without restricting it too much because, yeah. So I'm curious to see if we can get this into the database as is. You know, like I said, this is a dev database, and I've gone through sort of multiple iterations of the schema. And so the thing's a little bit of a mess. So if I run it across all the data, I'm never quite sure if it's going to run okay across all of the data. So yeah, it looks like at least in this limited query it worked okay. All right, so let's put this into SQL. I should check and see if I have any. Oh, here we go. XDDB built-in function including core do not need to be fully qualified. Interesting. Yeah, so does that mean built-in functions? Huh. Yeah, I'll just ask. So does that mean this this one should actually be fully qualified and just kind of working by coincidence here? I get the core, like the core functions don't need to be, but what about this one? I'm not sure what's meant by built-in in that statement. I'll check back in a minute. Okay. But I guess the clarifying thing there is you don't have to for core for sure. So I'm going to leave this for the moment, but possible this should be fully qualified. All right, so let's go back here and okay, so we'll put this in here as tags schema. By the way, just a meta note here. I'm debating whether I want to keep all the tags in the database. I might end up just rolling them up into summary stats initially, just for you know, I'm trying to operate on a budget here, and I don't know if the tags will blow up the data too much. That's the highest cardinality thing in the data. Okay, so this is tags schema. We'll just call this table tags. That's not a relevant comment for this, and we'll pull this out. I'm just going to throw this in here without any limits on it at all in terms of what it's querying. That may blow up Metabase, because Metabase, we'll see. We'll see what happens. There may be junk in here that like confuses the types, but we'll try it and find out. Oh, you know what else though? Yeah, we won't actually be able to see this. I'll query this from the command line, and we'll be able to see it there. Like I said, the Metabase, the thing that I'm interacting with from Metabase kind of got stalled out. I don't want to try to debug that on the stream, so it won't see, you know, it won't be up to date and won't get this schema change, which, you know, is probably something about the way I'm running it and has nothing to do with the database itself. I just haven't fully instrumented or debugged that portion of it yet, and that is not seeing me bang my head against like AWS containerization stuff. It's probably not the most productive way to spend time on the stream here. Okay, so let's get this fully set up, and I'll query it on the command line. So I'm just pulling these in like so. Okay. Okay. So we have, what is this? This is a keyword, big int, varchar, another varchar, another varchar, and finally another varchar. Pretty straightforward for this one. Okay. I'll just leave it all like that. Let's see. So we did run this thing. That looked fine. Schema. Oops, sorry. SQL, not schema. Tag schema, table name, table query, table columns. Looks okay. Looks okay. So let's evaluate that. Then over here, tag schema. Just make sure this pulls out the right thing before I transact that. Okay, boop. Looks right to me. Let me go back and see. Okay, yeah, that was my reaction too. I'm not sure how that's getting resolved either. Okay, so before I transact this, because you know who knows, I'm putting this in there. It'll be. Let me fully qualify this. Net strong pool dot indexer dot util. I think this is a safer bet. Little uglier in the query, but you know whatever. Especially since this is actually just a SQL schema, and we could hide some of this ugliness in rules too, which I'm not going to get to now, but we'll be. I'm sure that will come up in a future stream. Okay, cool. Still runs. Let's take these, put these into the SQL schema. Yeah, that's sort of a head scratcher for me too, because we're quoting this. I can't remember. Clojure doesn't actually resolve the aliases in a quoted form, does it? Or the yeah, I don't know. It's a little puzzling to me how that works as well. Maybe it does. I don't know. It's one of those things I don't think about a lot until you know something like this comes up. It's like, wait, how does that work? But anyway, better safe than sorry here. So we'll go ahead and fully qualify those. Okay. Submit TX. Okay, just double check that again. Okay, yeah, I got the right version. Submit that. Okay, now let's really quickly I just want to check. I'm just copying this because XT entity. I just want to make sure that my local database is all caught up with the transaction log. I think it should be because I don't think there was a lot of, I think the other thing that would be writing to it is essentially stalled at this point. So it's called node here. Yeah, okay, so it's xtdb, so I'm just going to query or pull the entity out for that schema. Tags schema, if I can type it right. Okay, cool. So that just is showing that the local database is all caught up. Wow, I got to dredge out of my memory the what is that thing called? Oh man, okay, I gotta look up. I think searching for crux will likely get me there faster. I just want to look up. I have done this before, but I always forget the command line for. Querying pages SQL. You know what? Maybe it's in the might be in here. Yeah, here we go. This is what I was trying to remember. I just don't remember this offhand. Okay, so let's do select star from tags limit. Might have to uppercase that. Well, let's find out. Let's limit 5, sure. All right, what are you doing? That's taking unexpectedly long. Interesting, why? Double check. Let's double check that the why would it be taking that long? Well, you know what? Let's try this. I don't know if that okay. Let me go look at the docs again. Looks like it should be fine. Let's try selecting the other table. So the other table is, what do we call it? Block underscore attributes. Okay, that works. Oh, wow, ow. Stop, 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 stop. No. Why would it do that? Okay, okay, let's see if we can. Okay, try again here. Limit 5. Okay, okay. So tags, let's see what happens. Tags, limit, can you just give me 1? All right, let's go back. Did I do something stupid in my query? But I ran the query too, so I'm not sure what's going on there. Unless it's something, no, I don't know. So one thing I did do, all right, where's my query? This is my query. I'm limiting it to 10. Is it something about keyword? Well, you know what? Okay, remote driver, blah blah blah. What's it saying here? Oh no, we are hitting some weirdness. It's makes me wonder how the limit gets applied. Yeah. So the problem is I have, yeah, now thinking about the history of this database, it makes sense too. So I have name values that are bytes in there, byte arrays instead of strings. And so when it's doing this, it's trying to treat those as strings. That's obviously not going to work. With the block attributes, well, you know what we can do? Okay, so there is a solution for that. Let's just add a couple joins in here. So we'll say txa id is arweave.tx.attrs. Actually, no, I did name that already, so you have to use. Oof. Is something still running? I wonder if it's still running somewhere. Yeah, I bet there's something running in the background that's messing things up. Let me see if I can kill these. Do I have another one open? No. All right, kill that. Kill this one. And what's this one? Those look like closure, okay. Yeah, okay. So I probably had some stuff running in the background there still. Ooh, I may have to kill the other ones too. Does not feel like yeah, it's definitely trying to do something and struggling to do it. I'll do it from I'll hopefully do it from Emacs here. Oh, I'm just going to kill all the Java processes. Ooh, Emacs is still slow. Why is Emacs still slow? Maybe it was Emacs that was causing me problems. They're not the... I thought it was the background JVM process, but... This is some peak streaming here. Sure everyone joins to see me kill processes. All right, let's see. Yeah, I think where I want to get here, I'll wrap up soon, but okay, yeah. So what I would like to do, I just want to put the same height restriction on this, but to do that, I gotta get a couple of joins in here. So let's do that, and then we want block. I gotta look up what that is. Indexer. So TX adder. Okay, so it's going to be block adders. Let's call that BA, and then we got. Oh, I got empty line in there. Okay. Block adders height. All right. So hopefully. Check my comments here. Okay, cool. Hopefully this let me just get these. All right, so indexer, I'm gonna test them out over here. Okay, so let's see. We have TX attributes. That's doing Arweave TX adders, block adders, going to block adders height. Oh yeah, and then we want to put in the height restriction here. And get my node connection going again. What? Really? 94? Huh. Got some garbage in there. Okay. Yes. Oof, okay. There we go. Okay, okay, it looks good. So let's try. Make sure we got the. Oh, nope, gotta go reload that namespace. Oh, and I'm missing the height restriction over here. Last little bit is kind of a yak, in the sense of yak shave. So, okay, let's try that. So. First off, oh, you know what? I evaluated the entity. I bet it was already reloaded. All right, anyway, that looks right. So let's submit this. And then that. Okay, so let's try this again. Okay. Let's see what happens. Still don't know why it's taking that long, but we'll see what happens. You know what we could do while we're waiting for that? Curious if I've got a mistake in here or what. So let's do just do count ID. I'll comment out these. Oops. Yeah, I just want to make sure that my join is working the way I think it is. Oops. Interesting. Is it really that bad? Oh, concurrent timeout exception, really? That's interesting. I wouldn't think. Oh, well, that one returned. Okay, it took a long, long time. And it did do the UTF-8 decoding. Now, need to think about why it would take that long. I mean, okay, so let's look at our Arweave data. View block, just do view block. Okay, so let's think about this for a minute. This is one of the reasons, by the way, why I'm thinking I may just store aggregate stats at the the block level for tags because of stuff like this. But I'm not fully convinced. Like, it doesn't quite make sense to me that it should take that long. Let's do this. Is there something going wrong? I don't see anything obviously wrong with my join though. So let's do this. Just stupid, like, yeah, just count all the things that have that. Okay, surprisingly long. That's interesting. I'm trying to think that through. Okay, so it's a, I don't know, that still seems slow to me. This does push me in the direction of thinking like, oh, no, I should aggregate these though. Because, I mean, even if I can make this fast enough, yeah. Even if I can make this fast enough, I think it's not gonna be ideal for me right now. Just in terms of the amount of resources I want to throw at it. So I think probably, you know, just from kind of a back of the envelope perspective, I might want this in the future, but I don't think it makes sense currently from a cost perspective unless I find some trick to trim that down. So let me explain though. So let's quickly do this because I think this might be somewhat useful. Okay, so TX adders. So this is the number of transactions. Let's do that. Oh, that one's actually relatively slow too. I wonder what happens if I do. Well, I'll have to play with this more and see what knobs I have to turn here. Probably doesn't make a whole lot of difference though, because I think ultimately a lot of this stuff I care about, I'm going to roll up to the block level. So let's take a look at Arweave data though, and just like some of the summary stats here on view block, and think about why. So the waters get a little muddy here recently because, let's see, they're doing daily by default. So let's look at, yeah. Let's look back here. Let's just use this. So what happened recently is they implemented bundles. Bundles are basically a way that you can take a top level transaction, a layer 1 transaction, if you want to call it that, of which there's a cap, right? So you can, the network tries to target 720 blocks per day, one every 2 minutes. I think in practice it's closer to 900, but you know, on the order of 1,000, right? So 1,000 blocks a day, and each block can have 1,000 transactions, max. So you're capped at a million transactions a day. This here is telling me that, of course, it's a little bit misleading because everything is it's all in one RocksDB index, I think. So part of the problem here is that let me think about this for a second. So I would have to think through exactly how it's executing that to think about it. But I think part of the issue with how all this stuff gets stored is I think it's just one key value space in RocksDB. So, I think all your attributes and all your object IDs, everything is going in there. And you'll probably get some locality benefits from the sorting. But I think it's still likely less optimal than having different like different tables or different. I'm not sure what the RocksDB terminology is. I think the reason it's implemented that way in XT is because not all the key value stores they want will have the same features, and so if you just put them all in one basically in one giant key value space, then it works consistently across everything. Downside is I think there's probably optimizations you could do that you're not doing from doing it that way. But again, all this stuff is slated to change. I think they're talking about moving to Arrow for indexes, and I think if you move to Arrow, then what I imagine they're going to do is probably have the attributes actually be like columns in Arrow. And then I think that would have a bunch of benefits. Like you'd probably, you could pull out individual, again, this is just talking from me, speculating about how this would work, but I would think you should be able to pull out individual sets of attributes. And then probably you just have one space for your object IDs, but they would be different. Not explained that very well, but anyway, I think probably you get better locality and better compression in that world. So yeah, anyway, back to the Arweave data. So the Arweave data, you're going to get maximum on the order of 1 million transactions per day. In practice, you see right now, it's more like 30,000, whatever, layer 1 transactions per day. And it spikes up here, but I think a lot of these are counting bundle transactions too, which is good if you're assessing how much utilization Arweave is getting, but not good if what you want to use this for is trying to think about how much data you have to index. So what does this mean in terms of the data we want to save? So we know that the maximum transactions per day we have to deal with is 1 million. And then we know that there's up to 1024. It's 2K. I think it's 2K worth of tags in terms of the bytes that they take up per transaction. It's either 1K or 2K. I think it's 2K though. So that means that your tags could be a multiple of that million. So you're talking about, I don't actually know what this would be a thing I'd want to compute, but you're maybe like 4 tags average per transaction. I don't know if that seems plausible. So that could be 4 million per day maximum, or not maximum, more like average if you're filling up all the transactions, because I guess maximum would be you have 1 character or a couple character name value pairs, and then you could fit a lot of them in there. Like, one of my concerns actually about this is that the indexing of these things is kind of a denial of service vector on the network, because there's a cost for storage, but there's no pricing of indexing of data yet in the network. So that's an area that needs to be worked on in terms of scaling Arweave. At the scale it's currently operating on, it's like this is not really that big a scale yet. So indexing this stuff uh, using some really scalable database is not like throwing in DynamoDB or something. Should not be a serious problem. But it will be eventually, if the network achieves its goals. But anyway, so that's all just to say that the tags result in a lot more data. And even if we're not querying them, all of that data has some impact on the index size, which I think will not. I think the impact of that will be mixed. I think the worst case for that, so I think the attributes would all be sorted so that similar attributes together would be together, but you're still going to have all those object IDs, and the object IDs are going to be randomly distributed. So I think to pull the object IDs out of the index, it's going to have an impact. Yeah, I think it's going to have an impact on how good a locality you get when querying the object IDs. And in terms of what that means for query execution, I'm not 100% certain. I have to go see what it's doing, but you would think that some of it boils down to having an object ID and then querying the attributes out based on the object ID. And that seems like it's going to be worse the bigger that gets. So that might argue for trying to, this is all me trying to conserve resources too. If I wasn't worried about cost, I might just throw a lot of hardware at it. And though honestly, my laptop is pretty fast system, so that tells me that I wonder what this would look like in MySQL. Sorry, I'm rambling now. I'm just trying to think through the implications of this. I need to do more experimentation and more digging into implementation. What that might mean for me is that I don't want to store separate attributes documents. Maybe I'll just store the attributes now and not preserve the original, or not preserve the original in the same XT database. But again, like this is all me trying to think about how to best utilize the resources I have available. I'm not sure that everyone should be making the same kind of assessment here. But it is interesting to think through these things. I should probably wrap up now because I'm definitely just thinking out loud and kind of rambling here. I think probably the main conclusion is I do think I want to just roll up the tags and index aggregate data for the tags at the block level. I don't think for what I'm doing currently, it makes a lot of sense to store the really highly granular per transaction tag data in a way that I can query in the data log queries. Because what I'm most interested in initially is being able to do summary statistics of the database. And in all honesty, like this is not even no offense to XT, this is not the ideal structure to put this in either. Like probably for the kinds of queries I'm initially interested in, a more optimal structure is like more of an analytic database style structure, which maybe when the transition to Arrow happens, this will be stored in that way more, so it will turn out to be better at that point. The reason I'm doing XT is because it's really nice to be able to do all the interactive development, and this is a very fast way to learn about the data. And I think ultimately I probably will be putting this in multiple formats for different use cases. And the one that XT should be really good at is if I want to do graph traversals of transactions or that kind of thing. Like that XT I think should be, I don't know about optimal, close to optimal. near optimal for that. And that's a pretty interesting class of queries to be able to run on a blockchain. So I'll stop rambling, wrap it up here. The thing we didn't get to is calculating the block reward for transactions. Some future stream, maybe next one, I don't know. I'll talk about like future topics here in a second, but that would fall into the bucket of trying to compute more block level summary statistics. Definitely something I want to do. So there may be a future stream where I work on that, as well as maybe computing these aggregate tag statistics too. Because I think that I'm pretty sure that's the direction I'm going to go in. And, some of the other finer details of like, do I say both the blocks and the block attributes? I don't know. That's, it's not the most important next decision to make. So yeah, in terms of like working on XT, I think that's probably the next area is computing those rolled up statistics to put on the blocks, or, documents adjacent to the blocks. And more broadly, I'm not sure exactly how I'm going to do this, but I've been thinking I will do some streams talking about Arweave in general, sort of walking through some of how it works and some of the properties I think make it interesting and motivating me to work on it in the first place. I want to do this because I've been explaining Arweave to people and sort of my motivations in working on it, and I have to explain that stuff. And if I'm explaining it off the cuff, I think I could probably do a better job if I just prepare a bit and sort of boil it down into some shorter YouTube videos that I can just share with people. And I think that would be more valuable to the community and save me time ultimately too. And I think there's a lot of kind of non-obvious things you get when you have a system like Arweave that can permanently store data in a way that doesn't change. And I want to kind of break that down and explain some of my thinking there, because I see people. So right now, the big use case for Arweave, this is totally fine. Like, people are storing NFTs on it, and if you're into NFTs, it certainly makes sense that you're going to want to store them forever, right? So because whatever NFT is worth, like whatever. I don't want to get into the value of NFTs, but if they're worth something, they're not worth as much if the image or video or whatever it is that your NFT is based on gets lost. So clearly, if you're into NFTs, you want the data to be permanent. That's fine. That's, these things have to figure out a niche where they can get some traction, and then other use cases will follow. That one in particular is not the most exciting for me. I think there are interesting things about NFTs, but it's not the most interesting thing. But I think there's a whole bunch of other things that are really non-obvious, especially not obvious for people who don't have a functional background or think about immutable data a lot. And I think if you kind of go through the properties of a system that has this permanent immutable data point by point and compare it to what we have now, say in the web or other systems, it will become clearer more broadly what the value of some of this is. So anyway, I want to try to explain some of that, and I'll probably stream some of that and then split the videos up into smaller chunks, because I know that these streams are a lot for people to process, and probably very, very few people go through a whole hour or like hour and a half stream of me rambling and writing code. And if I have some smaller things, I think that will be more beneficial broadly for people's understanding of this space. So yeah, that's more that's even more rambling here. So I'll wrap it up here at the end. Thanks for joining if you joined, or watching later, and look forward to streaming more in the future, and talk to you next week.